In this video, I'm going to show you how to calculate limits using trigonometric identities. So here's the first problem that we want to solve. We want to compute the following limit. Limit as x approaches 0 of sine x times the quantity 1 plus cosine x all divided by sine of 2x. Now, of course, the first thing that we always try with limits is we just try direct substitution. But in this case, direct substitution will give us just 0 over 0 indeterminate form. Feel free to check this yourself if you'd like. So remember, when direct substitution doesn't work, what we have to do is we have to manipulate the limit a little bit. We want to try to simplify it into a form where direct substitution does work. And whenever we have a bunch of trigonometric terms inside of a limit, it's a good indication that we might be able to simplify this limit using some trig identities. So just looking at the terms of this limit, sine x, 1 plus cos x, and sine of 2x, are there any terms that we know a trig identity for? Well, we know that sine of 2x can be written as just 2 times sine of x times cosine of x. So why don't we go ahead and sub that in for the denominator of the limit there. So the limit becomes the limit as x approaches 0 of, numerator stays the same, just sine x times 1 plus cosine x. But denominator is now 2 times sine x times cosine x. And hey look, some things cancel. This sine x in the numerator and sine x in the denominator, those cancel. Alright, so let's write our limit again without those terms, which canceled. Now it's the limit as x approaches 0 of 1 plus cosine x in the numerator, and in the denominator it's just 2 cosine x. And hey, since the sine terms are gone, the limit's not going to go to 0 over 0. We can just directly substitute into the limit, get 1 plus cosine 0. Cosine 0 is just 1. And then that's over 2 times cosine 0, which is just 1. So 1 plus 1 over 2 times 1, that's really just 2 over 2, which is equal to 1. So there we go. That's the limit. The limit is just equal to 1. Here's the next problem. We want to compute the limit as x approaches pi over 4 of cosine x to the 4th power minus sine of x to the 4th power, that quantity divided by 3 cosine of 2x. So again, if we try to substitute in pi over 4 for x, we're going to get the form 0 over 0. And you can check that yourself if you'd like. So since we've got indeterminate form, we have to manipulate the limit a bit. We have to simplify it before we try to plug in pi over 4 again. Now, one of the first things that jumps out at us here is the numerator. The numerator can be factored as a perfect difference of squares. So let's write down the limit again, but factoring the numerator this time. Limit as x approaches pi over 4 of, the two squares here are cosine squared and sine squared. Because if you square each of those, you get your cosine to the 4th and sine to the 4th. So we have cosine squared plus sine squared, then times cosine squared minus sine squared. And let's just leave the denominator as is for now. You might notice that we can expand this out too, but we'll just leave that step for after we've dealt with the numerator here. So first thing to notice here is that we've got a cosine squared plus sine squared. And we have this Pythagorean identity that sine squared plus cosine squared equals 1. So that says that this expression here in the parentheses, that's just equal to 1. So that simplifies the limit a bunch. Let's write it down again. Limit as x approaches pi over 4. This is just 1, so we can forget about it, because 1 times anything is just that thing. So just keep the cosine squared minus sine squared factor up top, and then that's still over 3 times cosine of 2x. Now you might say, why don't we just factor this numerator again? It's still a perfect difference of squares. We can factor it into cosine plus sine times cosine minus sine. But do you see any simplifications that would arise after we do that? It doesn't look like there would be any, so let's actually not go down that route. Let's instead look at this denominator here, 3 cosine of 2x. In particular, we know a formula for cosine 2x. We've got an identity for that. Cosine of 2x is just equal to cosine squared minus sine squared. And hey, that's exactly what we've got up top in this numerator. So if we sub that in, we can cancel. Let's go ahead and do that. Limit as x approaches pi over 4 of, in the numerator, cosine squared minus sine squared. And then in the denominator, 3 times this expression, cosine squared minus sine squared. So these cancel out of the numerator and denominator, those factors, and the limit simplifies a whole bunch. Now it's just the limit as x approaches pi over 4 of 1 over 3. And direct substitution on this limit, well, there's no x in the limit, so it just stays as is. It's just 1 over 3, 1/3. So there we go, that's the limit. Here's another problem. We want to compute the limit as x approaches 0 of cosine of x times cosecant squared of x all over the quantity 4 plus 4 cotangent squared of x. Now if we try to plug in x equals 0, just directly substitute, we reach a problem. Cosecant of 0 is 1 over 0, which is undefined. So direct substitution isn't going to work. We've got to manipulate and simplify our limit a bit before we try that again. Okay, so how can we simplify this limit? Is there anything that jumps out at us? Maybe looking in the numerator first, there's cosine and cosecant squared. Cosecant is 1 over sine, so unfortunately we can't cancel out anything from cosine and cosecant being multiplied together. But how about that denominator, 4 plus 4 cotangent squared of x? That actually looks really familiar to a trig identity that we know. That identity is just that 1 plus cotangent squared of x is equal to cosecant squared of x. And all we need to do in order to use that identity is factor out that 4 out of the denominator. So let's go ahead and do that. We'll write the limit again. Limit as x approaches 0 of cosine x cosecant squared of x over 4 times 1 plus cotangent squared of x. So now we can just go ahead and sub in for this expression here. And once we have that cosecant in there, we see that that'll cancel in the numerator with the existing cosecant squared up there. So this is a really good sign. We're canceling stuff in our limit. We're simplifying it. Maybe after this direct substitution will work. So let's write down our limit again. Cosine x cosecant squared x in the numerator. And then in the denominator now, we have 4 times cosecant squared x. So cosecant squared cancels on bottom and on top. And what's left over in the limit is just limit as x approaches 0 of cosine x over 4. And hey, the cosecants are gone. There's just cosine, and cosine has no problem when we evaluate it at an input of 0. So let's just go ahead and plug that in. Cosine of 0 is just 1. So the limit comes out to 1/4. So now we know how to calculate limits using trigonometric identities. And in the future, we'll continue learning about limits, including limits at infinity and infinite limits.